Could you imagine flying across the globe in just over an hour? Yeah, 1 hour. Well, you may not have to imagine for long, because today's video is all about a new high-speed jet that may change the aviation industry as we know it. Oscar Vinales, a designer from Spain, has created a new invention called the Hypersting. This aircraft is capable of traveling across the Atlantic at 3 times the speed of sound, which means it could transport passengers from London to New York in under 80 minutes. This is twice as fast as the current record holder, the Concorde, which completed the same journey in 2 hours and 53 minutes. The Hypersting is also larger than the Concorde, almost twice its size. The Hypersting is proposed to be 328 feet long and could carry between 130 to 170 passengers. It could potentially reach a maximum speed of 2,664 miles per hour, which is much faster than the Concorde, a previous record holder that measured only 200 feet long and could carry up to 100 passengers with a top speed of 1,354 miles an hour. For comparison, the average commercial airplane currently travels at a speed of around 460 to 575 miles per hour. If the Hypersting becomes a reality, it could mean that traveling from London to New York would be as fast as riding the subway from the Bronx to Brooklyn. This could make long-distance travel much more efficient, convenient, and comfortable for passengers. As you probably already guessed, this aircraft is aiming to become the fastest commercial passenger plane ever. It plans to achieve this by using a cold fusion nuclear reactor to power 2 ramjet engines and 4 next-generation hybrid turbojets. This technology is untested, but Oscar Vinales believes that the aircraft can reach a speed of Mach 3.5, which would be groundbreaking for commercial air travel. Until now, this kind of technology has only been used in military aircraft. The current fastest aircraft ever recorded is the North American X-15, which flew at a speed of 4,520 miles per hour, or Mach 6.7, on October 3, 1967, over 55 years ago. The Hypersting's success will depend on the success of this new technology. How soon can we expect to see the Hypersting? Well, keep watching to find out. You won't want to miss that info. The financial viability of the Hypersting is one of the most important questions that needs to be addressed. The cost of producing a high-speed aircraft like this is a key concern, especially given the financial difficulties that led to the discontinuation of the Concorde project. Despite these concerns, Oscar Vinales remains optimistic about the potential of the Hypersting. He acknowledges that the Concorde was an impressive feat of engineering, but argues that its environmental impact, noise pollution, and high operational costs made it unsustainable in the long term. Vinales admits that it will take some time for supersonic flights to return, especially with innovative systems like the cold fusion reactor. He estimates that the earliest possible production date for the Hypersting will be after 2030, and the costs will not be cheap. Which of course is to be expected when creating such a technological feat such as the Hypersting. What do you think? Do you think the Hypersting will ever truly get made? Let us know in the comments section down below. Also, if you're enjoying this video, be sure to leave a like and of course subscribe to our channel for more awesome content like this. Now let's get back to the video. So what has changed in the world of aviation that has made the Hypersting possible? Since the 1950s, aircraft designers have dreamed of fitting a nuclear reactor into a plane for cheap travel and longer flights. However, this has proven difficult due to safety concerns and the need to scale down the reactor's size to fit on a plane. While submarines can operate for decades without refueling thanks to nuclear reactors, it's more challenging to make them flight-worthy. The main concern is to prevent the reactor from emitting radioactive particles into the plane, which requires a heavy casing that could make the plane too heavy to take off. The issue then becomes how to shrink the reactor to fit onto a plane. Although Vinales claims to have a solution with his Hypersting concept, it remains an idea in his imagination. But he's not the first to come up with this idea. During the Cold War, the Aircraft Nuclear Propulsion Program in the US aimed to create a nuclear-powered airplane. However, despite years of research and $1 billion spent, the program was eventually cancelled in 1961 by President Kennedy. The only successful attempt to carry a nuclear reactor on board an airplane was the Convair NB-36H, but it was not powered by the reactor. While technology has advanced since then, nuclear-powered aircraft remain elusive. Instead, Boom Supersonic plans to launch a plane that can fly at 1,304 miles an hour, which is still considerably faster than current commercial airplanes. Now, because the Hypersting has yet to become a reality, why don't we take a look at the current fastest jet that's already been built and compare its specs to that of the Hypersting. The Lockheed SR-71 Blackbird, also known simply as the SR-71, is a strategic reconnaissance aircraft developed in the 1960s by Lockheed's Skunk Works division. It is widely considered the fastest plane ever built and still holds the world record for the fastest air-breathing manned aircraft. The aircraft was designed to fly at high altitudes and speeds, with the ability to evade enemy missiles and outrun any fighter plane. The SR-71 was a marvel of engineering, with a distinctive long, sleek fuselage and two powerful engines capable of pushing the plane to speeds in excess of Mach 3, or about 2,200 miles per hour. It was equipped with sophisticated avionics and surveillance equipment, including cameras and sensors that could detect heat and other signatures from miles away. The plane's incredible speed and altitude allowed it to take high-resolution photographs of enemy installments and troop movements from the safety of the stratosphere, far out of range of most surface-to-air missiles. It was also used for other missions, including mapping and atmospheric research. Despite its impressive capabilities, the SR-71 was retired from service in 1998, largely due to budget cuts and the increasing use of unmanned drones for reconnaissance. Nevertheless, the plane remains an iconic symbol of American technological prowess and military might. So what's the difference between this plane and the Hypersting? How has the technology changed since the creation of the Lockheed SR-71? Well, we broke it all down for you here. Design. The SR-71 is a jet-powered reconnaissance aircraft, while the Hypersting is a conceptual supersonic commercial aircraft with a nuclear fusion reactor. The SR-71 has a sleek angular design with a long, slender fuselage and delta wings, while the Hypersting has a more futuristic and streamlined body with a blended wing body. Speed and range. The SR-71 is capable of flying at speeds over 2,000 miles an hour, or Mach 3, and has a range of over 3,000 miles. The Hypersting is designed to fly at speeds over 1,500 miles per hour, or Mach 2, and has a range of up to 8,000 miles. Propulsion. The SR-71 is powered by two Pratt & Whitney J58 turbojet engines with afterburners. The Hypersting is a conceptual aircraft that would be powered by a cold fusion reactor, which has not yet been proven to be feasible for aviation use. Cost. The SR-71 was an expensive aircraft to build and operate, with a cost of around $33 million per aircraft in the 1960s, equivalent to around $300 million today. The Hypersting cost of production is not yet known. However, its designer, Oscar Vinales, has stated that supersonic flights using innovative systems, such as a cold fusion reactor, would not be cheap. We can definitely say we cannot wait for the Hypersting to be unveiled, which of course begs the question: just how much would high-speed air travel change society? Well, for starters, faster air travel could help to further integrate the global economy by facilitating faster and more frequent travel between countries. This could help businesses to expand their operations to new markets and increase international trade. It could also encourage greater cultural exchange and cross-border collaboration in various fields. It would also be easier and more affordable for people to visit exotic and far-flung destinations, which could provide a boost to tourism and hospitality industries. It could also make it easier for people to attend conferences, events, and other gatherings in different parts of the world. You also have to take into account the jobs this would create. The development and deployment of high-speed aircraft could create work in a variety of fields, including engineering, manufacturing, maintenance, and operations. This could have positive economic effects on communities where these jobs are located. But not all positives would come out of this. Despite the potential benefits of high-speed air travel, there are also significant concerns about the impact it could have on the environment. The aviation industry is already a significant contributor to global greenhouse gas emissions, and the increased use of high-speed aircraft could exacerbate the problem. The high speeds required for supersonic flight, in particular, can result in higher levels of emission than conventional aircraft. However, aircraft manufacturers are actively working to address these concerns by developing more eco-friendly and fuel-efficient aircraft. For example, many aircraft manufacturers are exploring the use of sustainable aviation fuels, which can reduce emissions by up to 80% compared to traditional jet fuel. Additionally, there are efforts to develop more fuel-efficient engines and aircraft designs that can reduce emissions and improve overall efficiency. In the end, it's difficult to say for certain whether the Hypersting will be made. While the concept is intriguing and has generated some interest, there are still many technical and financial challenges that need to be overcome before it could become a reality. The aviation industry is highly regulated, and any new aircraft would need to meet stringent safety and environmental standards. The development of a new supersonic passenger jet like the Hypersting would require significant investment and resources, and it's not clear whether there would be enough demand for such an expensive and technically complex aircraft.